Thanks everyone, welcome back to my channel. In this video, we will see how does Kubernetes works. Let's understand the architecture. Kubernetes works in a client and architecture approach. What is mean by client and architecture? Now, if you have taken tools like Ansible or Terraform, what it will do is, there was only one server which did everything, right? But however, now we have multiple servers, and this is where we have to divide those servers into the two parts. One is called the master, or technically we can call it as a control plane, and another group of servers which we called as worker nodes, or technically we can call it as a data plane. So basically, the actual servers in which your containers are going to run, those are called as a worker nodes or data plane. Okay. However, you don't have to go to the each server and tell what to do. That is the reason you will have another part of Kubernetes running on separate server is called control plane or master. So the name says control plane means it controls everything. So basically, you go to the master or control plane, you tell what is your desired state, and Kubernetes master will connect to all the worker nodes and it will handle what to do. Whether it is running, not running, scaling, doesn't matter. So as a user, you don't have to go to the any worker node or data plane. You will just communicate with the master or control plane. That's it. So how do you communicate? So once again, we have some tools for that. You have UI, or you can also use command line utility. So this command line utility which we use for Kubernetes called as a kubectl or kube controller. We will see now. Okay. How you are running Terraform or Ansible, so now you will run the kubectl commands. So in which you will give the YAML file which has your desired state, and that will be read by the master or the control plane, and that will be take care of everything. That means it will connect to all other things where and all it is required. So you communicate only to the master or control plane, and the control plane will handle everything on that data plane. Okay. So now let's get little deep inside it and see how it works. We will see that in depth actually. So as I told, Kubernetes cluster is divided into two things. One is called control plane, another one is called data plane. Just remember this. Now when you are trying to work with that Kubernetes, first we need command line utility which is called kubectl. Okay. So you should have to define all your requirements in one YAML file. Then that YAML file you will give it to the kubectl, which is called kube controller. Now the first thing is kubectl will communicate to the control plane, but what will happen inside? Again, from the technical point of view or interview point of view, it better to you need to understand the architecture in the little deeper. Okay. So now this is where, so there are various components in control plane and data plane. So in real time, your control plane can have also on the multiple servers. Your data plane will definitely be on the multiple servers. So first in control plane, there is one component is called API server. Okay. So when I say API server, it's a small programs which does some particular activities or particular task. So as a user, when you first give your desired state, then the kubectl read your YAML file and it will give it to the API server. So for different tasks or different activities, there are different APIs will be available, which we will see. So the basic understanding is you give the YAML file with your requirements to the kubectl, then the kubectl will send it to the API server. Next thing is, once the API server reads the information from your YAML file, it will store it in one location called etcd. So etcd is like, you can consider as a small database in which when you give YAML file will be in key and value format. So that key and values will be stored into the etcd. For example, I told I need 5 containers or 10 containers. For that, what image to use, what volume to map, what port to map, what startup command to use, all those things you give it as a desired state, and that is now stored into the etcd. Okay. Then what is happen? In control plane or master, you have one more component is called controller. So this is the one which will be controlling everything like a manager. So what will controller now do is, its the duty is to very frequently check the etcd and it will find out what is your desired state. So what is there in etcd now? Your desired state, which is API server read from the kubectl and it will be stored. So what will controller do now? It will read the etcd and it will find out your desired state. Okay, but what is there in actual state? So that will be controller will know it actually. So that is where controller will know both the things. It will know the desired state and it will know the actual state. Now, as soon as it find out there is no containers in that actual state, then controller will create some information. So that is what we will call it as a workload. Workload means it will have to create containers. So where it will create? Okay. So this is where what will controller do is, like a manager, it will call a TL who will take care of everything, right? Similar to that, here there is one more component called as a scheduler. So controller will create a workload saying that, hey, this guy want to 10 containers or 5 containers, but I did not see anything there in the actual state, which is called worker nodes. Please go ahead and create. And then that workload will be received by the scheduler. So what is the duty of scheduler here is, it's a actually schedule. Schedule means where to create, and this is when the scheduler will find out in your data plane whether you have 5 servers, whether you have 10 servers, 20 servers, 50 servers, which server has the capacity and where it has to create it. That will be taken care by the scheduler. Okay. Now how does scheduler know which server or which machine has the capacity? So this is how in the data plane what is happening. The data plane means not only one server. You have multiple servers are there. Now each of the server you will have Docker is running. Okay. So on top of the Docker, you need to install and run one more component is called kubelet. Okay. So kubelet is the component which will run on each worker node in the data plane. Its duty is to collect the workload from the scheduler or read the information about the servers and give it back to the master or control plane. So that is how your master knows what is happening in each and every server. How many servers are running in data plane, how many containers are running, how many containers are rebooted, all those information will be got it from the kubelet. Okay, so this is where scheduler will now tell the server 1 has the capacity and it will send that workload to the kubelet on that mission, and kubelet will now receive the workload, and finally what it has to do is to create a container. Okay, so kubelet will communicate your container management tool like Docker and it will create the containers. Same way, now container is running. Now controller duty is to continuously check with your desired state and actual state. So it will check the etcd for your desired state, and with help of kubelet it will try to know what is the actual state, and if there is any difference it will immediately create the workload and it will send it to the scheduler, and the scheduler will be sent it to the kubelet and the kubelet will be created. For example, if one server has crashed, that server has the two containers. So in that case, controller will easily know desired state is 5, actual state is 2. So then it will tell to the scheduler to go and create a containers. Then the scheduler will go and check on which server has the capacity is there, and it will send the workload exactly to that server, where in that server kubelet will receive it, it will create the container. That is how the kubelet uses the tools like Docker to create the containers. Now, apart from this, on the data plane, there will be one more component which is running. That component we can call it as a kubeproxy. Okay, so kubeproxy helps you with the networking part, accessing the containers. All those things will be helping, because as a user you don't have to worry on which server the container is running, and you don't have to worry on which replica of your container is running. So that is where kubeproxy will help you with the certain IP addresses which we'll see. Okay, so you can access those containers, those applications from the outside of the cluster in such a way that the kubeproxy will be helping with you. Not only accessing part, it will be helping you to do the load balancing and other stuff. So this is how in the real time you have control plane and data plane will work. Okay, so let's conclude on this. So once again, now if you understand how the traffic flow or how does the architecture works. So first, as a user, you will run the kubectl with the help of your YAML file. That YAML file read by the API server. It will be stored into the location called etcd, and then controller will read the etcd and it will know the desired state, and it will check that actual state coming from the kubelet, and if there is any difference it will create a workload and it will give it to the scheduler, and then scheduler find out which server has the capacity and it will send that workload to the data plane on the same server. In the data plane, kubelet will receive that workload and then it will communicate to the Docker or whatever the containerization management tool, and it will create the containers, or it will delete, start, stop, restart, recreate it, whatever you want, that will be taken care. And the same way on the data plane, so that is on the worker node, you will also have another component called kubeproxy, which can be help you to accessing your pods, load balancing, networking, all those things will be taken care by the kubeproxy. Okay, so and apart from that, so pod is the deployment unit, so that has that multiple containers. Just remember this. Now you don't have to run all. The only thing is you will be executing the kubectl, but internally all those things will be happening. Okay, so this is how the Kubernetes architecture will work. Thanks for watching.